I'm going to start you off with a high-speed input housing for a gearbox. That was one that had a bad bearing fit down inside there. So I machined it out, machined a sleeve, and put it in there and actually welded it in place. That's what I'm sharing there. Is I TIG welded it to keep the sleeve from trying to back out. And then once I welded it in there, I set it back up in the lathe and bored it to size. And we got a little clip showing the whole assembly together here. Here's the high-speed assembly put together. There's the shaft. This is the input. That's your input shaft. He's already got it together. It worked out good. So here I'm machining out the new sleeve. I bored it out, machined the sleeve, shrunk it in there, and now we're finishing it to size. I got this thing finished out. I finished it at 7 inches, 87 thousandths, just a shade over 180 millimeters. This is one of the bores that actually requires a slip fit on your bearing, not an interference fit. So we've got just enough clearance. And if you look in the back, that darker line in the back there, that's your original bore. And you can see that it was actually bigger than my sleeve there, and it's consistent all the way around. I measured that about 4 thousandths over the bearing. So we're going to have about 1/1000th slip fit, and we got a good smooth finish in there using a high-speed tool. Let me rotate that around. Just a piece of high speed, finely honed, and we got the proper back rake and side rake there. Using my Starrett inside and outside mic. I mic the actual bearing to compare the fits too. So I still got to face that off even there. And we've got to mill this out right here. That's an oil channel to oil the bearing right there. Scraping in that sleeve. I'm going to try to capture some of it there. Just hand working at the full width of that tool bit. Just hand working it when we get it done now. I decided to take one of my largest angle plates and clean it up on the bore mill here, clean up both sides, and get it as flat as I can. Now those are some good tools. Those are some of the top quality import, cast iron angle plates that my dad bought years ago. And I've got a job plan for that on my shaper, and that's why I'm cleaning it up. I've got some other angle plates which I always use on that board mill that I'll show here in just a second. And these two fabricated angle plates are not completely square, so I want to use the shaper to shape those things square again. I'm going to use that cast iron angle plate to hold those. So we just finished up our grinding job from the day. That was the first journal that I was grinding in earlier. 6.5 inch on the diameter. And then this is the other journal that I just finished right there. So both of them are seal journals. So that's a seal fit there. This is 2 thousandths under this. This is where your bearing goes. You have a spacer that goes right here. This is where the large gear goes right here. And then you have bearing, seal, and then that's your output. So that one's ready to go out of the lathe and go to the back. Here's our housing finished up, bored out, and then pressed in, cast iron sleeve, and the white numbers is what my tolerance was, and then the black number there is what I hit. Finished with a piece of high-speed tool. Turned out pretty good. That's the bar set up there. This one takes a 3/4 tool, and these are the tool bits right there. This is the one for boring, and then this is the one for chamfering. So this is one of our EMD gearbox rebuilds that Dylan is working on. Dylan, what are you doing right here?
All right, we're doing the acceptance testing after we've rebuilt the gearbox. We just finished our vibration test. We have a vibratory limit of 0.15 inches per second, which is already passed. It's blown it out of the water. We also had to do an oil discharge test to measure and make sure there's no oil passageways blocked. And the next step is a rundown test. And basically we're going to kill the power to the motor and wait, and it should take greater than 3 minutes for it to actually stop turning.
Okay.
And that will just show that there's no rubbing or obstructions.
Well, it looks and sounds good, man. Good job. There's an example of a convenient use of the horizontal boring mill. This is a pretty simple bracket that is used to hold a pump for transportation, and modifications being made to it to hold a different style pump. And Junior asked if I could put some holes in it for it so he can bolt that bracket to the red frame there. So I got 2 of them marked there, and we got 2 of them marked there. You see how easy it is to mount it over here on the boring mill and drill it with the spindle there versus standing it up in the vertical mill. Just makes it real easy right here. Got me a fresh grind on that 33/64, and we're ready to put some holes in it. Nothing to it. Nothing to it. Notice the Booth machine clamps holding them together there. Okay, we got them drilled. Easy peasy. Real simple job for the board mill here. So generally on carbon steel or mild steel, whatever, anything like that, I run typically around 60 to 80 feet per minute on the cutting speed. That would be for your drill bit, end mill, things like that. In this particular application, I was running 60 feet per minute. And how do we know that? I was actually running it 444 RPM for this drill. 0.262 times 0.515, that's my drill size, times 444, 59.9. That is your feet per minute. That's your cutting speed. That's a piece of 6-inch 4140. I'm removing a 1/2 inch 22 thousandths feed rate. Roughing in another gearbox shaft. There's the shaft we're making right here. Running 186 on the RPM. Now on this pass we kicked it up a little notch, but we're only taking a 1/4 inch off. That's going to bring me within 60 thousandths of my finished size in the middle. That's a 25 thousandths speed rate. And we're running 235 RPM on that one. .338 surface feet per minute. 0.262 times 5.5 times 235. So about 338 feet per minute is what we're running there. We got the first end of the shaft finished out. This is the shaft output side. This journal here measures 4 3/4, and the next journal right here, that's your seal. That's your seal journal, 5 inches. And then I got the radiuses machined in there. And for the radius, I use that tool right there, top notch, 1/8 radius. It's a 1/4 inch wide tool. So we're going to flip it around and get these sides finished out. So I'll finish this. I turned this for the steady rest for the radiuses there. So these 3 journals will all be machined together. That's a bearing, gear, bearing. Okay, we've got the shaft is finished. All the lathe work is done. Time to go to the milling machine with it and mill the 2 keyways. Alright, all the lathe work is finished. The shaft is completely turned and it's ready to go to the milling machine for the 2 keyways. So we got our bearing fit there. This is our bearing fit, gear fit, bearing fit, seal, and output. Let's look at the old one again and we'll see why we had to make this. This is our sample. This is the one that we're copying right there. Now the one obvious is the seal groove. You can see the seal groove right there. Pretty good groove in it. But if you'll look on the output side of the shaft right here, it's got a lot of wear in here. We'll put the scale on there. Look at all that. See how far under it's worn. So that's a problem right there. And then you also have wear in the key there, and you can see where it's been rubbing the side and the bottom down in there. You take the key. See how loose it is. So the keyway is actually stretched. Alright, it's stretched open right there. You see it's broken right there. And it's really loose. So time for a new one. So we're finishing out the keyway on the gear fit journal there. We're making our finished cuts using an 1 1/4 2-flute end mill. And it's cutting 10 thousandths on all 3 sides, each side and then the bottom. It's just cleaning it up. There's our fit on our other side there, an 1 1/4 key. There's our keyway finished up. Got a stack of gauge blocks in there, 1.249. And then of course our key, and that's the key that goes there. Alright, so we got a good fit there. Just got to do our deburring and then we'll be done. Alright, we're going to go ahead and pull these things off. Take that probe out. And take the meter out of there. We are going to attempt to lift that like that without breaking it. Get up underneath it. Trying to stick there. Those things should just fall apart. Look at that right there. Alrighty.
It's beautiful.